Alright, welcome to this video series on how to create a payments dApp leveraging an OpenZeppelin smart contract. My name is Ayuba Ojanubomwazu. I'm a software and a blockchain developer from Nigeria in Africa. And welcome to this new and exciting series of creating a payments dApp leveraging on the OpenZeppelin smart contract. Now, OpenZeppelin, we are going to look at what it is, and then we're going to look at how is effective and efficient in leveraging on this technology to make our smart contract development very easy. And I have to tell you, majority of the smart contracts that have been developed in the recent years have actually leveraged on one way or the other on OpenZeppelin. And if you go to their website, you can see that they made a claim of about saying that about 4.something billion US dollars has been saved on the blockchain using their smart contract, leveraging on their smart contract. So getting to know about OpenZeppelin and the classes or the contracts, the predefined contracts that OpenZeppelin has will make you to at the end of the day be a better smart contract developer. So we're going to start with this very basic and simple payments dApp, but yet powerful, and we're going to leverage in the OpenZeppelin network, of course, and then get to see how we can use that to ease our development process. So stay with me while we get started. Thank you very much. Okay, welcome to session 1 on this video series on how to create a payments dApp leveraging on OpenZeppelin smart contracts. So in this session 1 here, we are going to look at the overview of OpenZeppelin contracts, and specifically we're going to discuss the different kind of contracts that has been predefined on OpenZeppelin, like contracts that has to do with access control, that is ownership, then contracts that have to do with tokens, in which of course we have payments, generating tokens, subcurrencies, and the rest. Then we're going to look at contracts that have to do with gas station network, GSN. We're going to look at in the GSN contracts, the idea actually is a system where your dApp users don't pay for gas. So we're going to look at that. Then we're going to look at the different APIs that OpenZeppelin has, payments APIs and the rest. They are all smart contracts actually. We're just going to discuss that briefly and just have an overview of OpenZeppelin and why it's important in what we're going to design, and why OpenZeppelin is important in the smart contract world. So first thing, just head to their website. Let's start from there. You go to docs.openzeppelin.com, and then we just have this. So we'll just read through their documentation, and then just to have a small overview of what it's all about. But you can still go to their website, openzeppelin.com, and get to see that. Let's go to openzeppelin.com first before we go to docs. So openzeppelin.com, and let's see what they have to say there first. So you can see the first thing they have here is we're hiring. So this should show you that if you get to know how to write contracts leveraging on OpenZeppelin, then of course they are hiring. So at this point now, the standard for secure blockchain application, OpenZeppelin provides tools to write, deploy, and operate decentralized application. We also protect leading organizations by performing security audits on their systems and products. So you can see, first of all, it's a security audit firm that has set the pace among others. So what they're able to do is to create different smart contracts objects or classes, if you can call them, and a whole lot of companies have leveraged on that to have their application or their dApp up and running. So you can see the world leading projects trust OpenZeppelin, and these are very this is a leading project actually. We have the Brave browser, Argo, Ethereum Foundation, Coinbase, BitGo, Compound, and the rest. So you just head through their websites. They talked about the challenges of building decentralized application. Of course, security is one of the major challenges, and then of course reduce barrier to entry by securely implementing blockchain based technology using standard developer tools and platforms. So what you should just know in mind is OpenZeppelin takes security very serious. So their smart contracts and smart contract APIs are all targeted towards securing your smart contract, and of course making your development life cycle very easy. So you can see we have contracts. They have contracts, of course, the different smart contracts, SDKs that you can use and starter kits, and then of course the library of modular, reusable, secure smart contracts for the Ethereum network retaining solidity. So OpenZeppelin actually it's more of a Ethereum based smart contracts. So you can see you have this, and you can just read through these, and then of course you can see they have starter kits, bundles to kickstart your decentralized web application, build upon the most popular React setup. If you're a React developer, this will be very easy for you to start. Interactive tutorial to assist your first dApp, ready to go scaffolding with Web3 connection. But if you're not a React developer, no problem. We're going to create a dApp or payment dApp, and then you're going to see how this whole thing works and how OpenZeppelin is making life easier for blockchain developers out there. So you can go to their forum, you can read their documents, in which it's what we want to go through. So learn everything you need to develop blockchain application through a complete set of guides and tutorials. So if we go to docs, which of course will take us to docs OpenZeppelin, which is where I was. So you can see the first thing is why OpenZeppelin. After the documentation here, OpenZeppelin tools have been built with security in mind, just like I said. And since the first release of the contracts library in 2016, our libraries have been downloaded over 1.5 million times to create tokens, protect digital assets, empower decentralized applications, securing more than 4.5 billion US dollars. That's a lot of money. So we also work with top Ethereum projects through our security audit services. So you can see here on the left pane here, you can see a whole lot of things they have. You can learn, you can get to view the contracts, you can get to see the CLI, starter kits, and the rest. So what we're going to do, you can scroll down, it's still the same thing here. And then of course there are different tools they have, which were focused more on the smart contract, to get to see the library of different smart contracts and different scenarios that they have. So let's just go right and go to contracts. Good. So you can see a library for secure smart contract development built on a solid foundation of community written code. So of course we have you can go to their GitHub page and you can make your contributions and the rest, and then of course I will take you there to see how you can download some of this. So you can see implementation of standards like ERC20 token. I believe you know what ERC20 token is, but if you don't know, I'm going to run you through that in a short while. Our flexible role-based permission scheme, reusable solidity components, first-class integration with the GSN, which is the gas station network for system with no gas fees, audited by leading security firms. So we have different contracts here, different contract scenarios here that OpenZeppelin created a library for. So let's start with access control, and then this has to do with ownership. Like I said, access control, that is who is allowed to do things. So you have scenarios where you want to create a kind of application where of course you want to place access control. You want to define who should be allowed to do some certain things on your application. So it's a nice idea If of course if you're creating a smart contract that has to do that. We live in that kind of world today where you just can't give the entire control of your tokens or smart contracts to an unknown person. So there has to be some restrictions and some sort of access control. So it's incredibly important in the world of smart contracts. The access control of your contract may govern who mints tokens, vote on proposals, freeze transfer, and many other things. Well, in our payment dApp, we're not really going to go deep into access control, but we are going to see how important it is. And then of course they have this nice smart contract that they wrote. They call it the ownable smart contract, ownership and ownable smart contract. So you can see that the most common and basic form of access control is the concept of ownership, of course, who owns something and who is allowed to do something that that person owns. So there is an account that is the owner of the contract and can do administrative tasks on it. This approach is perfectly reasonable for contracts that have a single administrative user. So OpenZeppelin provides ownable contract for implementing ownership in your contract. So if you're thinking of designing an application, the app that has to do with ownership, then head to OpenZeppelin and then you get to see contracts that has to do with ownership. So you can see they just give us a little sketch of the contract, how it looks like. First of all, you import the OpenZeppelin ownable contract, and then you modify it, you inherit it, and then you can have functions like a normal thing, anyone can call this function, and then function like a special thing, only the owner, and you can see the keyword here, only owner can call that. So that's the concept of ownership. That's the concept of access control. So ownership, who owns, and then who is able to do something. So that's ownership. Then the ownable contract, like they said here, allows you to transfer ownership or renounce ownership. So you can decide to say, okay, I'm transferring ownership to this particular user in our organization to be able to perform administrative tasks on my behalf, and then you can renounce ownership. You can decide that, okay, I don't want you to do that anymore, I don't want you to do administrative tasks anymore, I want to renounce your ownership. So here, removing the owner altogether will mean the administrative tasks that are protected by only owner will no longer be callable. So you just need to put that in mind. Then they said here, note that a contract can also be the owner of another one. So you can design a contract that owns another contract. So they said this opened the door for using, for example, Genesis multisig or Safe and Aragon DAO and ERC725 you port identity contracts or a total custom contracts that you create. Well, anyway, that's that. Then we have role-based access control. Like I said, you can decide in your organization that, okay, we want this particular user to perform accounting task, we want this particular user to perform admin role, we want this particular user to moderate who performs what. So when there's ownership and when there is transfer of ownership, there should be role-based control. So if you're thinking of an application that has to do with that, in which I'm going to do a video on that very soon, then you should think of the access control library with different ownership and role-based smart contracts that OpenZeppelin has predefined for us, in which we can inherit from and then, you know, make our application to be much more secured and easy to use. So you can see they give an example here of a kind of payment in which we're going to do this very soon, but we're not going to do the role actually. So but we're just going to do this. So you can see they give an example using roles. OpenZeppelin provides rules for implementing role-based access control. Its usage is straightforward. For each role that you want to define, you store a variable of type role, which will hold a list of accounts with that role. Here's a simple example of using roles in an ERC20 token. I'll talk about ERC20 token later. We'll define two roles, minters and burners. So minter is just who mints a token, and burner is who should be able to burn the token. So, well, anyway, what you should just know is you can create contracts that can assign roles to some specific users based on your business rules. Then let's head back to tokens. Let's head to tokens rather. Now with OpenZeppelin you can create tokens. Look at what they said here. The token blockchain is most powerful and most misunderstood tool. Actually, most blockchain applications are designed mostly with tokenization in mind. So a token is a representation of something in the blockchain. It could be anything. It could be a digital certificate, it could be a sub-currency, it could be a land, it could be a representation of physical assets on the blockchain, and different kind of things. So this something can be money, like they say, time, services, shares in a company, a virtual pet, anything. By representing things as tokens, we can allow smart contracts to interact with them, exchange them, create or destroy them. So that's tokens actually, and it's well explained there. So a token contract is simply an Ethereum smart contract. Spending tokens actually means calling a method on a smart contract that someone wrote and deployed. So at the end of the day, a token contract is not much more a mapping of address to balance plus some methods to add and subtract from those balance. So there are different kinds of tokens actually, fungible tokens, non-fungible tokens, and the rest, but we are not really going to go like so deep into it, but I will just explain what it means. Now there's a difference between having 2 voting rights and 2 deeds of ownership. Each vote is equal to the others, but houses usually are not. So this is called fungibility. So let me just read it for you all. Fungible goods are equivalent and interchangeable, like of course like Ether, your money, the fiat currencies you're using, voting rights and the rest. While non-fungible goods are unique and distinct, like deeds of ownership or collectibles. So in a nutshell, when dealing with non-fungible, like your house, your car, you care about which one you have, while a fungible asset like your bank account statements, what matters is how much you have. So that's just the difference of that. So under the tokens we have ERC20 token, ERC721, ERC77, but we're just going to focus on ERC20 tokens. And then ERC20 token has been the first token standard in the blockchain world, and a whole lot of companies have created ERC20 tokens. Oh, my internet is going off. Let me get to see. So our payments, the app that we're going to create, will leverage on ERC20 tokens. Okay, something is okay, good. So now I have this. Now ERC20 tokens contract keep track of fungible tokens. So we just described what fungible tokens are. For example, your bank statement, your fiat currency, and the rest. Now any one token is exactly equal to any other token. No tokens have special rights or behavior associated with them. This makes ERC token useful for things like medium of exchange, currency, voting rights, etc. So the OpenZeppelin contract provides many ERC20 related contracts. So depending on your business scenario, what you want to achieve, there is an API reference. You will find detailed information on their properties and usage, and that's where we have this. So you can design tokens that has to do with crowd sale, ownership, different kind of things, payments, and the rest, access control, and all that. So in our system, we're going to create an ERC20 token that will do some basic things like transfer of tokens, minting of tokens, creating tokens, just like printing money. We'll just look at the currency world, the monetary world. So we're going to mint tokens, which is like printing money. We're going to be able to transfer tokens, which is like exchanging money between one person and the other. Then we are going to look at allowing someone, approving someone to spend tokens on our behalf. For example, it's like giving someone money to maybe pay salary on the company's behalf or something like that. And then we are going to burn token at the end of the day, just the way the central banks destroy currency when it's too much in circulation. So we're going to just do that. So that's what our payment dApp is going to carry, and I'll explain that in the next video. But like I said, you can go right ahead and go to the OpenZeppelin docs, that's OpenZeppelin.com, and look at contracts and look at the different kinds of contracts and details they have. But to get a full understanding of all this, we're going to create a payment dApp that will leverage on these, and you can see at the end of the day why OpenZeppelin is so important in creating smart contracts. So okay, we're going to have that, and okay, I'll just show you next maybe how you go to the GitHub page and download the different smart contracts library that we have, and how you can use that in your application. So stay with me until the next video where I just explain how our dApp will look like before we go into coding the smart contract. Thank you. Hello, welcome to session 2 on this video series on how to create a payment dApp leveraging an OpenZeppelin smart contract. In this session 2 here, I'm going to take you through the interface that we're going to build, or rather the application that we are going to build. And because I've built the application, so we're just going to look at it. And then these are the features of what we are going to capture. We're going to capture mint tokens. Our payment dApp should enable us to be able to mint tokens into supply, make transfers of those tokens, approve another account to spend those tokens on our behalf, and then bond tokens. By bonding tokens, we are reducing the total supply of our tokens in circulation. So what we are creating, actually, we're creating a subcurrency for payments, subcurrency for payments on the blockchain. So that's what we are going to do. Now, we're going to have this interface. This is our application that we are going to create, payments dApp, and you can see here, this is home. Welcome to OpenZeppelin payment dApp. You can see I have a smart contracts address, the token name, token symbols to supply, and then when you click to check balance of logged in account, you can get to see the balance, which of course you can see the balance is quite different from the total supply. Now, when I say logged in account, is because I have this little guy here installed called MetaMask. Now, MetaMask is a bridge between our browser and the blockchain. So, what is MetaMask? Let's go to MetaMask website and get to see what it is. So, go to metamask.io, go to your browser, go to MetaMask.io, and then read all about it. Now, make sure that your MetaMask has HTTPS because we're talking about money. So good, HTTPS metamask.io. Now you get this. So you can see what it says here, brings Ethereum to your browser, and then it says get the Chrome extension. Now MetaMask, as of shooting this video, works only on Firefox, Brave, and Chrome browsers that I know. So it doesn't work on Internet Explorer. So you can see as you move your mouse, this guy follows you around. So you can read about it. You can see MetaMask is a bridge that allows you to visit the distributed web of tomorrow in your browser today. It allows you to run Ethereum dApps right in your browser without running a full Ethereum node. So consider it, imagine running a full Ethereum node, downloading the entire blockchain into your laptop or your desktop. It's not just possible as it is now, because the blockchain has grown so huge. So we don't need to run the full Ethereum node. We don't need to download the entire blockchain history into our computer to be able to connect to the blockchain world. So MetaMask enables you to do that, and then it includes a secure identity vault, providing a user interface to manage your identities on different sites and sign blockchain transactions. So just like these our sites, of course, is localhost. It's localhost. So MetaMask now will give us the ability to be able to connect this outside to the blockchain world. So which is an example of what I just did now. So go right ahead and install MetaMask. So if you're using Chrome like me, just go right ahead and click get Chrome extension and follow the procedures. But keep it in mind that you need to save your 12 seed phrase. You need to write it down, and store it somewhere, more especially if you're going to put in real money, real ether in your MetaMask. So make sure you do that. Now once you have your MetaMask installed, which is pretty straightforward, the next thing is okay, let me just run you through the application. So we have this. that we're going to create our token based on OpenZeppelin smart contract. So we're going to create our token, and then we're going to have this interface, and then we should be able to mint tokens. So once you click here, we should be able to add more tokens to supply. So for example, we want to add more tokens to these accounts to increase the total supply of tokens. We have 14990. So this is the account, so we want to add more tokens here. So you see this account has 14970 700 14990. So we want to add more tokens to the supply. We come here, and then we want to add it to that account. Let's say we want to add 100,000 more tokens to this. So the app should be able to do what I'm about to do now. So you can see by clicking mint tokens, it pops up MetaMask, and then I'm going to sign this transaction, and then the transaction will now be recorded onto the blockchain forever. And that's the beauty of the blockchain. So okay, all right, good. So contract interaction, I'm about to send some tokens. I have to add more tokens to the supply. So I click confirm. Now if everything goes fine according to how I designed the application, this should work well. Okay, I think it's going to work. Okay, so it has been submitted. Let's just wait a little while. MetaMask will give us a message whether the transaction was successful or not. So let's just wait a little while. Good, transaction 156 confirmed. View on Etherscan. So Etherscan is like a website where you view all the transactions that has ever been recorded on the Ethereum blockchain. So there's a transaction hash, which is the key that you can use to view all your transactions. So anyway, you can see we've added 100,000 tokens. So if you go back to home, you will see we have 14990, which will now increase, I believe, to 15990, right? Because we added, okay, to 24990. So we've increased the total supply of our currency. And then when we click here, you can see we'll have 24970. So that is what we are going to create. We're going to mint tokens. We're going to transfer tokens. Our application should be able to transfer tokens. You know, let's say the logged in account wants to transfer tokens on another account. We enter the recipient account address here, and then the amount we want to transfer, and then we initiate the transfer, and then approve spending. We want another account, you know, to spend our tokens on our behalf. Take a look at it rather like a company that, you know, wants to fund the accounts department to be able to pay its employee salaries. So this is a perfect scenario. So the admin will, or rather the accounts department will request for money to pay the salary, to pay the employee salary, and then the admin will approve the accounts department to spend, say, a certain amount, so that that can be paid to the employees. So that's what we're doing here. So we'll approve spending, we'll approve another account to spend on our behalf. So without really giving the money to that account, we just approve them to spend on our behalf. Now, and then finally, we're going to have bond tokens, which will decrease the total supply of tokens that we have. So we're going to decrease, we're going to bond some tokens that if we see that's, you know, to reduce inflation and all that. So this is what our payment dApp is going to carry at the end of the day, and we are leveraging all these on OpenZeppelin. Once we go into smart contract development, once we start writing the codes, you will know I will introduce you to Remix IDE, which is much more simpler to write our smart contract instead of, you know, downloading and trying to download different platforms like Truffle, Ganache, and the rest. So well, anyway, this is about our payment dApp. This is how the interface is going to look like. So in the next video, we shall start coding the interface, and then the smart contracts, the Web3 parts, deploy our application, and we get it up and running. So thank you for watching. Welcome to session 3 on this video series on how to create a payments dApp leveraging an OpenZeppelin smart contract. In session 3 here, we are going to create dApp interfaces, and we're just going to create an interface that's similar to this. So you can use any text editor to do this, but I'm going to use Visual Studio. I've done this before, so I'll have to do it again. So on my Visual Studio, I just go to new website. Now, like I said, you can do this on any text editor because we're just focusing basically on the HTML files. So it's just HTML and Web3 JavaScript. That's what we're doing. We're not really doing anything more. So because of that, I'm going to select empty website, and then I'll call this payment dApp 2 because I've done this before. So I'll say payment dApp 2, right? So make sure it's on empty website, and then I click OK. Okay, payment dApp 3. Okay, all right. I think I've created payment dApp 2 before. So payment dApp 3. Now I have my empty website here. Payment dApp 3. Let me start by go to Bootstrap. Go to the Bootstrap website and put my internet on, and then download Bootstrap. So we are going to use that, but before I do that, let me just go add, and then add new item index.html. so let me create the folders, the files rather. The first one, okay, I'm using HTML. So I have my pages. I have index.html, the first one. Just like these, I have index, I have mint tokens, mint, transfer, approve, and bond. So that's how I'm going to name them. Index.html. I add another file, mint.html. mint.html. Then transfer.html. 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 approve.html. approve.html. And then lastly, bond.html to remove tokens from supply. Bond.html. So okay, now I have this 1, 2, 3, 4, 5. I have 5 files starting from the index. I'm gonna put my internet on now so that I can go to the Bootstrap website and show you how you can download Bootstrap. So because we're going to need it in our design. Okay, I think I put my hotspot on. Good, so I'm connected now. Just quickly go to open, I think it's open Bootstrap. I think I have the website here. Good, getbootstrap.com. So just go to getbootstrap.com, docs 4.3. Yeah, that's the version I'm currently using, and you can, this has the latest version as out of this shooting of this video. So just go there right away and just download Bootstrap. So you can say Bootstrap or download Bootstrap to get the compiled CSS and JavaScript source code, or include it in your favorite package managers like NPM, RubyGems, and more. So just go right and hit the download button, since we're using we're doing this using HTML files. So you just download that. Once you download that, I've done that before, and then I think I have it in my downloads. This is this. So this is Bootstrap. So you just download the entire files, and then what we're interested in is just the CSS and JavaScript files. So you copy this, and then add this to your project. So now we have this. I can start. Let me start from the index page. So I pick the minified version of the CSS file, which is this, and then I just drop this here. So make sure you have this part like this. So we now have the CSS file, so we can call the CSS classes to simplify our HTML design. So okay, now that we have that, let's quickly program the index page. So let's say div. Let's start with a div like this, and then div class row. So div class column md3. Then we have our h1 here, and we call it payments dApp, right? Just give a space. So we call this payments dApp. Okay, good. Then we have a div class column md9, and then now we can put our nav bar, right? So put the list here, nav bar, nav tabs. So I give a space of p4. Okay, let's start with the button first. Oh, sorry. Start with a class and make this a button. Button info. So if you don't want to type all this, we're going to upload this in the project resource so you can download them and use. So this is the home, and then of course we index.html. So we'll copy the whole thing similarly. So here we have a mint transfer approve and bond. So reference the appropriate navigation. So we have mint here. We have transfer here. We have approve here. And then last but not the least, we have bond. So okay, we have this. Can I view this? Let me view this. So let's view this. Okay, good. So this is in line with what we designed. Okay, here we say mint tokens transfer approve spending bond tokens. Okay, so let's name them like that. Mint tokens transfer mint tokens. Mint tokens make transfer approve tokens, approve spending rather, and then bond tokens. So I guess we can refresh this again. Okay, good. So we're almost having what we have in the other video, in the other page. So now we can program each of the pages, starting from the index, and then program it starting from the index, which is the home, right? So of course we're on index now. You can just go ahead and then make it look almost like what we have here. So we say, welcome to OpenZeppelin smart contract, OpenZeppelin payment the app, and then we have all this, right? So I guess we can start like this, div class. Yes, we can start like this. Column MD12. Centralize the text center. So we'll just put our history and say welcome to OpenZeppelin payment the app. Okay, good. Then now we can have the rest. So we say div class column MD3. Give a space, and then text center. So here we display our smart contract address, smart contract address, right? Then we have these again, div class column MD2 P3 text center. So here we're just going to write our smart contract address 0 by maybe F blah blah blah, something like that. Okay, then let's end this whole space. So just a div class column MD7 because we have 3 plus 2 5 plus 7 makes it 12. So the same thing, we have smart contract address. We're going to have the same thing for token name, token symbol, and total supply. So I'll go right ahead and pick all this. So I say token name, token symbol, token name, token symbol, and then token name, token symbol, and total supply. Total supply, total supply. Good. Let's run this and see. Okay, good. So I have a smart contract address, token name, token symbol, total supply. Then let's put a button here where we can check the current balance of the account that is logged in on MetaMask. Just exactly how we have it here. So check balance of logged in accounts. We're going to have the account address and then current token balance. Okay, good. For that, I can just quickly pick this. So it's pretty much the same thing. I think I need to put P, maybe 3, to give a space. So we can pick this. And then I drop this, change this, and put a button here. So I will say, what did you write here? Check balance of logged in accounts. Check balance of logged in accounts. Okay, good. So then what's remaining is I can just pick this like this straight, just to ease development and make it fast. Account address, and then account balance. That is a logged in account address and logged in account balance. Account balance. So good. So I can go right ahead and name and give all these names. So for the smart contract address, we're just going to write this. Then for the token name, I can just give the div a name. Just ID, let's say X name. And for the symbol, X symbol. X symbol. And for total supply, I have X supply or X total supply. X total supply. Then for the account address, let's say ID X address, and then X balance. X balance. So if we refresh this page, good. So we have it now. Smart contract address, token name, token symbol, and total supply. So this should happen on the page login. We should fill this information, and then we check our logged in account address and balance. Now we go right ahead and quickly fix the mint token, make transfer, approve spending, and bond tokens. These all have similar interfaces, so we're just quickly going to run this up. So since we're basically going to have the same thing, so okay, I'm seeing payment dApp here. Why haven't I refreshed this? Okay, good. Okay, so the mint token is going to be the same interface that we have with this. So let's just copy this, all of them. Control C. Let's go to mint, and then let's drop that. And then we'll make a few adjustments. So we'll drop our CSS file from here. We'll drop that here. So we just say add tokens, mint tokens to increase supply. Mint tokens to increase total supply. So we're going to mint this into an address. So address, let's see, recipient address, the address we want to mint token to. Or recipient account address, and then I can pick this. should be in here. So I can say this, I can call this X account, and then recipient address, and then value as amounts. I can call this X amount or X value. I think X amount is better. And then we can just quickly modify this a little bit by I don't think we need this, we don't need this anymore. We don't need these anymore, but I think we need that button. So here I'll just change this to mint, and then I'll change this to column MD2. Pick all these, drop it after this, make this 5. Good. Let me see what I have here. Mint tokens. Good. So mint tokens to increase total supply. So we enter the recipient account address, the amount, and then we click mint to mint these tokens. So I can just change to mint tokens. Now it's going to be similar interface for both transfers and the rest. For transfers, approve and burn. So just pick everything, go to transfer, drop this, and then we'll see transfer token from one transfer token to other address. Transfer tokens to another address. So recipient address, the amount. So here it's going to be the logged in account that should be able to make that transfer of tokens. So good, because we're going to look at the smart contract and it's going to be like that. So now I take this and then I drop this here. Okay, so the next thing now is going to be approve. So we'll go to approve.html and then we drop that. So approve spending for another account. Approve spending for another account. So the accounts that should be able to just say account address, let's remove this recipient, and then the amounts that this person should be able to spend. So we'll just say approve spending, and then we drop this here. Now finally burn, right? Burn tokens. So I'll pick this whole design here, drop it here. So I say burn tokens to decrease supply. Burn tokens to decrease total supply. So account address, I want to burn the tokens, the amount I want to burn, and then here we'll just change this to burn tokens. Burn tokens. Then of course we drop these here. So we save all. Now we can check our interfaces to make sure everything's okay. We have the home. Good. We have the main tokens. Good. We have the make transfer. Good. We have approved spending. Good. And then we have bond tokens to decrease total supply. So okay, good. So we have this one. Now here's how our interface is going to look like, our dApp. And we now, in the next session, we are going to write the smart contract leveraging OpenZeppelin to be able to conform with this design that we have. So thank you for watching. Hi, welcome to session 4 on this video series on how to create a payment dApp leveraging an OpenZeppelin smart contract. Now in this session 4 here, we are going to begin by creating our smart contract. And since we're leveraging an OpenZeppelin, our contract what will our contract do at the end of the day is to inherit from the predefined or pre-built contract that has been designed by the OpenZeppelin framework. So if you go to OpenZeppelin website, docs.openzeppelin.com, you could remember in the very first video I actually took you through this, and then I explained the different contracts that they have and in different libraries that they have. So now we are going to create our own contract. We are going to call it ERC20 payment, which will inherit from contracts in the access control, the roles contracts in the access control, and will also inherit contracts from token. So we that's what we are going to create. So what you need to do is first of all, go to GitHub. Just go to GitHub and then download the. Just go to github.com. Just click on GitHub, just the way I clicked on it, and then go to OpenZeppelin contracts here. Go to this page, or you look for it, and then because we're going to use the Remix IDE to avoid complex installations and the rest. So once you're here, you go to contracts, and then make sure you download all this. Just make sure you download, or you just download the contract folder itself. You can just clone or download. Just clone or download this. Just download all this here. So you can just go right here and then download everything here. So we're going to focus on this. So once you've downloaded that, I've downloaded mine, which is in my downloads. And then you can see this is OpenZeppelin contract master. So if I open this, this is everything I've downloaded. Now you come to contracts, and then you can see the different contracts, the different contract library. We'll have access. If you click here, you see we'll have rows.sol. So if you come to a token, for instance, you can see ERC20, ERC721, ERC777. So, and these are the solidity files or contracts in ERC20. So we have the ERC20 itself, the bondable, the capped, detail, pulsable, token time lock, and the rest. So you can go through all these contracts and just get familiarized with with that. So once you have these in your system, then we are going to build our contract, like I said. So go to remix.ethereum.org, and then it will give you this new version. So if you click on this, it will take you to the older version. So for example, if we click reload, it's take you to the older version, but it's pretty much the same thing. But since we have the new version, I don't see any reason why we should work with the old version. So but just to show you how it looks like, this is the old version. So as you can see, they're having a warning here telling us that the instance of Remix will be updated to the new interface pretty soon. So please check it out. Afterwards, the old interface will still be available for a little while. So this is the old interface, but now we are working on the new interface. So let's switch back to the new interface. So let's switch back to the new interface. Now we are going to create a contract called ERC20 payment that will inherit from ERC20 and ERC20 detailed. So those are the first. So since we're inheriting from ERC20 and ERC20 detailed, let's go to ERC20. So what we need to do first is to add local file to the browser storage explorer. So let's click on this, and then let's look at the ERC20 Solidity file. So we'll go to contract, it's in tokens. So let's pick ERC20 first. So we have ERC20. Now, if you look at it, ERC20 is inheriting from GSN and IARC20 and maths, save maths.sol. So let's create this folder, GSN and maths, so you can see how our inheritance is working at the end of the day. So let's create that folder. We can click on this and just create a folder, call it GSN, that is gas station network, and then we'll create another folder called math. Create another folder, so you just right click, create another folder called math. Did I create that? Okay, create folder, we call this math. Good. So now in the gas station network, we are going to put this solidity file context.sol. So we're going to look at that. So you make sure you click on this, the arrow is down, and then you add file from local storage. See, it's here, and this is what we're interested in. Oh, we didn't add that in here. Oh, sorry, I need to delete this. That should be in the folder. So you right click, sorry, and then okay, I want to add this from here. I guess we'll call this interface. It's okay, I guess I just have to create it from here. So context.so that's the name, right? So we have it here and it's open here. So I guess what we just need to do is let's open it manually and copy the contents in there. So I can open this with my notepad, you know. I can open this with my notepad, very easy. So I just copy the contents, select all, and these are predefined contracts that OpenZeppelin has created for us. So I just paste this here. Oh, I think I need to copy this again. Let's copy these again and then paste everything here. Good. So we paste this, and we will come back to look at each of the contracts one by one. So now we have the GSN and the context. Then the next one is math. We need to save maths for arc20.sol. so we need save math, and then we need this interface arc20.sol. so for math, let's did we create the math folder? Okay, we need to create a folder called math. Okay, we created math. I went and added it in GitHub, so I need to delete that. So I think you have to be careful in creating this folder. You just have to make sure you created it correctly. So oops. Create folder math. Good, so it's on its own now. Or did I open all this? I need to close all this. These are the default Solidity files that Remix created for us, so we don't really need all this. So these four Solidity files, we don't need them. So for math, we need to add save math, right? So create file, just how we did that, and then we look at the name math, right? Okay, it's save math. Make sure the naming convention, you follow the naming convention correctly. So save math.sol. So we have these now in math, and then I think we need to copy that too. We need to open that, select all, copy, paste this here. So we have the save math Solidity file. Now let's still go back to arc20.sol. we need iarc20.sol, and that is in the arc20, that is in the token. Good, so it's this, we need this. Now we can just quickly add that. Quickly add that. So we add file. Make sure if you're adding it, it's not the ones that are inside the folder should be inside the folder. The ones that are not inside the folder shouldn't be inside the folder. So that's how it goes. Now let's add this file from local storage. So this is what we need. Good. Now all these files do not inherit. This is an interface. Actually, this is an interface itself, and an interface, it's just a standard defined. It's not a contract you can actually call. It's just like a framework. It gives a framework on how the contracts should be built. So I'll explain this when I explain each of the contracts in detail. Now we have this. So we have this complete. We have these complete for the ERC20. Now I say we also need the ERC20 detailed, right? So let's look at that too. ERC20 detail, let's add that. ERC20 detailed. Good. So here is ERC20 detailed, and then it inherits from ERC20, which we already have that here. Now let's fix everything correctly. So let's start with ERC20. So you can see here it says we're importing from GSN context.sol, but we have just the first file GSN. We don't have any other file here, so we just remove all this and we leave the first dot. So this will correctly go to GSN. text.sol. Then for the maths tool, it's the same thing. We just have these like this. So we have maths, save maths.sol. So you can see, if you look at this tab, our Solidity compiler has compiled that. Now so the next thing is we'll look at this. Do we have any problem here? No. Here is okay, here is okay. Good. Now, in case you're not having all these tabs that I have here, if you're using this new interface, you go to settings, you will see well, I've added all the tabs, but if you come to settings here, you scroll down, it will enable you to add each of the tabs that you want to add, and then you can change the theme, the look and feel of this whole interface. If you want to, you can change it to, like I'm using Flatty Light, you can change it to Pulse Light or Cyborg Dark, or anyone that's most preferable to you. So that is that. Now if you see here is where we have all the files, File Explorer. Here is okay, this is a Viper tool that I added. You can actually remove it if you want to. You can actually remove this if you want to from the list. Then we have the compiler, Solidity compiler, where we can compile our program. Then we have this, deploy and run our smart contract. So I'll just work with this three, this one, File Explorer, the compilation, the Solidity compiler, and the debugger tool. So let's go back to our File Explorer. Now let's start from the beginning. Let's start from gas station network. Let's look at context.xol. Now look at what it said here. OpenZeppelin said here, provides information about the current execution context, including the sender of the transaction and its data. While these are generally available via message.sender and message.data, they should not be accessed in such a direct manner. Since when dealing with GSM meta transaction, the account sending and paying for execution may not be the actual sender as far as an application is concerned. This contract is only required for intermediate library-like contracts. So you don't need to touch this, you don't need to modify anything here. You just leave it as, because we're just inheriting from this, and you can see what the OpenZeppelin framework has said about this. Then for safe maths, you can see wrappers over Solidity arithmetic operation with added overflow and checks. Now the idea of this safe maths is to reduce overflows and underflows, so you don't need to modify this too. Arithmetic operations in Solidity wrap on overflow. This can easily result in bugs because programmers usually assume that an overflow raises an error, which is the standard behavior in high-level programming languages. Safe maths restores this intuition by reverting the transaction when an operation overflows. Using this library instead of unchecked operations eliminates an entire class of bugs, so it's recommended to use it always. And if you look at how they did it, you can see function. What we just had here, we have function add, where we can add just two numbers, you know, like A and B, and then it's required that if you're adding two numbers to get the result C, it requires that C is always greater than A to not to have an overflow. And if you're making subtraction, this is how it's supposed to be. So if you're making subtraction, it's required that B is always, if you're making subtraction of B from A, it's required that B is always less than or equal to A. So these are the checks that you look at. And using require, using this keyword require is to like check. It's like saying if, just in the if else statement that we have in normal programming language. And for multiplication, the same thing. You look at it, it's required that C divided by A is always equal to B. So this is just safe maths, you know. And division, the same thing. You look at it. So that's that for safe maths. Now we'll start with the interface ERC20. Now this is an interface. An interface of ERC20 standard as defined by the EIP does not include the optional functions. To access them, see ERC20 detail. So this is just to give us how our framework, ERC20 token framework, should look like. We need total supply, we need to check total supply of the tokens in circulation. We can check the balance of an address, like we check an address, we want to know the balance of tokens in that address. We can transfer tokens from one address to another. we can allow another address to spend on another address behalf. We can approve an address to spend on our behalf. We can transfer from, sender, recipient, and amount. And then these are events. If a transfer function is carried out, this event should be executed. And if we approve another account to spend on our behalf, then this function should be carried out. So that's that about ERC20.SOL, the interface ERC20.SOL. Then ERC20 itself, we have this. So it's an extension. If you look at it, you'll see it's an extension of context and ERC20. So what is added here is we have our private balances, allowances, and total supply. So here we've defined our total supply, and you can see we've modified the function a little bit, that to call this function total supply, which is here. So we've declared this variable, we've declared this variable total supply, and then we'll return it here by calling this function. So for balance off is the same thing. We declare this variable balances, and then we'll return it here. So I believe for allowances, we're going to see that too. Okay, for transfer, so if we're transferring, we make sure that it follows this. We're transferring from the account that is logged in currently, transferring from that account to recipient account, and then amount. So it means if we're running this, if we come back to our interface, if we're going to run make transfer, you can see we didn't specify the account from, so it's just recipient address and amount. Why? Because we already know the account that is transferring from our MetaMask. The currently logged in account will be the accounts that we're transferring from. So that's why this is like this. That's why we'll have the message to sender as the first argument. Then for allowances, the same thing. We're allowing an address to spend on our behalf. So we have address the owner and then the spender. So, and then we have that. Then we have approve, of course. So you can see the sender, which is the current login account, the spender, and amount. So we're going to use that function, and then you can just read through all these and see the requirement, because the green the comments here shows the requirements of what it's all needed. So you can see that ERC20 is extended. It's extended completely from ERC20. So you scroll down, you can see we have mint here. It requires that the address should not be a 0 address, and then before we mint, we look at this function before token transfer. So, which I believe if you scroll down to the last, you will see that. So address from, address to, and so you can look at the conditions, calling conditions. So you read that. But what basically is here is that first of all, the address must not be 0, and then when from is 0, amount tokens will be minted to. When to is 0, amount of from tokens will be burned. So that's just the idea here. So you can see we have mint and then we have burn. Good. So the idea is just to reduce the total supply when we look at this function, and for mint is to add to the total supply. Then of course approve on our behalf, approve an account to spend on our behalf, and we'll make sure that the account we are sending to, approving to, is not 0, and we ourselves, we are not a 0 address. So these are what we all have, but now this is a very detailed ERC20 token, more detailed than this because this is an interface. But now let's look at ERC20 detail. Now we've added name, symbol, and decimal. So the name, it's the, if you look at ERC20.SOL from OpenZeppelin, we don't have the name of the token or the symbol or the decimal, but this now we've added that, the name of the token, symbol, or decimal. So, and then the constructor of this application shows that if we're calling this application, if we're inheriting ERC20 detail, we have to provide the token name, the symbol, and the decimal places. in which we're going to do that shortly. And then the name will return the name, the symbol will return that, and then decimal. So this is just pretty straightforward and very simple smart contract. Now you can also extend this to have ERC20 detailed or ERC20 more detailed, inherit from this, and you can create another private variable like maybe country, country, where this just they will have name, symbol, and decimal. You can add country, you can add state, you can add different things that you want to add. But now in our own ERC20 payment, we're going to add we're going to assign rules to addresses that can mint tokens. So I think we need the roles .sol. So let's go back and add that. We need the roles .sol. Let's go back and add that. So here we come here. That should be in roles, ownership, right? Access, that should be in access. Good, roles.sol. So this is just to create a mapping of addresses that can perform some functions or not. This is to add those addresses or remove those addresses. So you can see we'll add those addresses to our storage or we'll remove them. So in reading all these contracts, you just need to know what all these libraries are. Just like if you're designing ASP.NET applications, you inherit a whole lot of library. You inherit from system.io if you want to perform operations that has to do with the input output. You inherit from SQL clients if you want to perform operations that has to do with SQL Server, that has to do with inserting records into the SQL Server database, and all other programming languages where you can inherit or import from different libraries. So these are libraries created by OpenZeppelin in which we can inherit or import from them. So you can go to their website, like I said, read all about it, know which library is for what. Like access control, you can see what they say here. Decide who can perform each of the action on your system. For tokens library, create tradable assets or collective and distribute them via crowd sale. So this is another library called crowd sale. So gas station network lets your users interact with your contract without having to pay for gas themselves. Then utilities generate useful tools including non-overflowing math, signature verification, and trustless payment systems. So you can, these libraries, you just learn to read all about them and decide how you want to add each of them to your application to make it more robust, because these are tests. These are libraries that has been tested by a whole lot of smart contract developers out there. So now let's create our own smart contracts called ERC20 payment. So we come here, we add a new file. So we'll just create a new file here. And now let's call these ERC20 payment.sol. So it's going to be an extension of ERC20 and ERC20 detailed, so we can add just a few aspirations of our own. So let's start. Each Solidity file, you start with Pragma. This is just to tell the Solidity compiler which of the compiler you intend to use. So as sort of this, I intend to use a compiler is above 0.6.0. In doing this, you have to look at all the compilers you're inheriting from, the Solidity files you're inheriting from the smart contracts, and you can see they are above this. If you scroll up, you can see it's above this. So I'm in line. I'm in line with all this. So you can see them. Okay, so let me go back here. Now, of course, since I'm inheriting from ERC20 and ERC20 detail, I need to import. Now, one thing about this OpenZeppelin, you mustn't bring, for example, let me import. I'm importing this ERC20 detail, for example, detail.sol. Now, if I don't want to bring all these like this Solidity file into my system, I can actually, add the GitHub. Since I know that GitHub is always online, I can actually open this contract. Oh, where's my GitHub? Did I open the GitHub page? Okay, good. I can actually come to this contract, and add this part here. GitHub.com, OpenZeppelin, contracts, 3 masters, blah 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 blah. I can actually add that here. I can just import from that place directly by putting this path. So if I want to get that particular contract itself, I can add this part. ERC20 detail, right? I can just go to token. Come here. So you can see I can add all these parts here. I can pick this and just say import with that part. So it's pretty much the same thing. Here's what I mean. I can pick all this like this. And import this straight. So you can see it's loading that. You can see Remix is identifying this. So I can actually do it this way, or I can do it this way by bringing them one by one into my project and then work on it. But let's work with what we've already started. So I can just remove this like this. So good. Now so let's import what we need to import. ERC20 as well. Import roles. So we've imported all this. Now let's create our contracts. Each contract, when creating a contract, you start with the statement contract ERC20 payment. So here's ours, right? So we're inheriting ERC20 and then ERC20 detailed, right? So we're inheriting this. So now using roles, if you look at the roles contracts, you understand what I'm saying here. Roles dot role roles dot role. So we declare this private minters, and then bonus. That's accounts that can mint tokens and accounts. So you can see what we're doing here. We're doing access control bonus. So good. So now I create my constructor. An array of address called minters, an array of addresses called bonus. Store this in memory. Now we call the ERC20 detailed, and we give the token name, the token symbol. So the token name, I can say my open token. That's my OpenZeppelin token. MIOPTKN. So maybe that's a token symbol. And then of course 18. It's always good to use 18 decimal places. So we have this, right? So we come here, we say public. So we do this for loop statements for UI for int 0256 is equals to 0. Once I'm done with this, I will explain. Mintus. So we look through this. Mintus. We add to this Mintus. So the same thing we do for bonus. Copy this. So change this to bonus. Change this to bonus, right? Then we modify our mint function that we have. So we modify our mint function that we have. Okay, I need to be careful about this opening and closing braces. We have these. I think we need one closing brace here. This close this, right? This close this. This close this. And then this should close this. Good. I'm seeing this error. What does it mean? Okay. We need this here. Now we create a mint function. Function mint. Address 256 amounts. We'll make this public. It's always good if you open, you close it back. Then so only minters can mint this. That's just what we want to do. So we look where we use our check require. It's only minters. msg.sender. That is only the account that is logged in can do the mint. So if the account is not logged in, we just say does not have minter role, does not. Minter role. So if everything is okay, then we mint to and amount. So it's the same thing with bonus. So I can just copy this whole function, create another function called bonus. That's bonus, sorry. And then of course only bonus can do this, as addresses that have been assigned the role of bonus can do this. So it does not have bonus role. So we call this will be from address from. So good, I believe I can reduce this. Just to make sure that everything is okay. Still have to be careful, this ends this. Okay, I guess I have to remove this. Okay, bonus with 1s. Minters at length, type error member length not found. length, not htch. That's how you spell length, right? Good. So I believe I've fixed all the errors, and you can see my contract has been compiled successfully. Now that's because I set auto compile to be true by checking this. But if you didn't check auto compile, you have to compile this manually by clicking on this button here, and then it compiles your contract successfully. And in compiling your contract, of course, you have to make sure that this contract is open and is waiting. So now this contract has been compiled successfully. I think the next thing is just to deploy the contract. We go here. Now there are different ways you can deploy this contract. If you're logged into MetaMask, it's best you come to injected web3, because that's what we're going to use. So injected web3 will select automatically the accounts that is logged in. So since we're going to deploy this on Ropsten network, we don't want to use our main network because we don't want to use real gas. So just go to your MetaMask. Make sure you're on Ropsten network. When I look at these ethers on this, I wish I had this number of ether like this. Okay, so just make sure you're on Ropsten network by clicking here and making sure Ropsten network is selected. So now you have this. Now in deploying the contract, now you have to be very careful. I have to show you. Make sure you select the ERC20 payment, because these are all the contracts we've inherited from that we are using to get to this. So make sure you select this, the one that is written ERC20 payments. That's the contract we want to deploy. And you can see it's asking us for the minter's address and the bonus address. So we have to define this first, which is already in our constructor. So we're adding minters. So you can see for this, for I equals to 0 to minter's length, we need to add at least one minter address and one bonus address. So that's why we're having this. So I think we can just pick the default account we want to use. I can pick this and copy this account. And since this is an array, we need to put these like this. Same thing, because it's an array of accounts of addresses. So put this. If you want to add 2 more addresses, you can put comma and then another address like this. So let's transact. Let's deploy this contract. Good. So you click on confirm contract deployment, sign this transaction. You can see this is our transaction hash. We can open this on Etherscan to watch our contract, in which I believe the contract has been deployed successfully at this point. Okay, creation of this contract is still pending, so we can come here to watch our contract. Okay, good, it has deployed, so successful. Now this is a Robsten testnet transaction only, so here is our contract address. Now we can copy this and save it because we want to use it later. So I can just put this on my notepad, copy this somewhere, or you can leave that page open. Good, so we have successfully deployed this contract and we have our smart contract address and everything is okay. Now in the next video we are going to interact with this smart contracts from our Web3 and mint tokens, transfer tokens, approve another account to spend the token in one token at the end of the day, just to show what we have done. So thank you for watching. Hi, welcome to session 5 on this video series on how to create a payment dApp leveraging an OpenZeppelin smart contract. In the last video, we were able to create our smart contract and then our our ERC20 payment smart contract. We were able to use access control to define which account should be able to mint tokens and should be able to bond tokens. So we actually extended our ERC20 and ERC20 detailed smart contract to create this ERC20 payments, and then we inherited from the roles smart contract, from the ERC20 smart contract and the ERC20 detailed smart contract to be able to create this ERC20 payment smart contract. And basically what we did here was to create an array of addresses. Let's create an array of addresses and then assign each of the addresses that we created an array of it when the application is starting. The constructor of the application, when it's starting, we created an array of addresses in which we just added only one addresses just for the minters and bonders. And then we're going to give we gave minter roles to those addresses. So minter and burner roles to those addresses. So that's what we are able to do. We did this by extending the OpenZeppelin contracts of ERC20 and ERC20 detailed. So now let's interact with our smart contract through Web3 so that our interface here will become very functional. So we start with the first page, which is index.html. The smart contract, we've copied the smart contract, which is this. If you remember, I told you to copy down the smart contract, so I can pick this now and then drop these in title, in our index rather, sorry. So here is the smart contract address. So we have that, which is this place here. So if you refresh that, you will see. Okay, the next thing now is we want to display the token name, token symbol, and total supply. What is the token name? This is the token name that we define. my open token, my OPTKN, and then currently the total supply is 0 because we've not minted any token yet. So let's display that. So we are going to use our Web3 object, and to do that is very simple. Like I said, make sure your MetaMask is installed, up and running. So we're going to write the Web3 JavaScript. So we'll just start with script. We can do this, and then so we run this on window load. So window unload. So we check for the Web3 objects if it's truly installed. So type of Web3. If it's undefined, like for example, if we run these on Internet Explorer, then we should have this error. So if this is undefined, then let's display the error just somewhere here, above here. I can let's just give ID here. The first div we can just say MetaMask. Oh. Okay, good. MetaMask. So we say documents dot get elements by ID. Of course, MetaMask. Inner HTML. You need to install MetaMask to run this. You need to install MetaMask to run this dApp. Good. Else, if there is no error, then let's create a function called getValue. So I'll just call the function here getValue. So I'll go down here and create the function. So I say function getValue. We could put this in our try and catch block. Try and catch block. Try and catch block. Right. So we're going to capture our error. So we'll put this in our try and catch block. Now we start with the ABI. So we declare it. What's a variable ABI? Now what is the ABI? Application binary interface. It shows the, here is where we get the ABI. It shows the detail, the description of our application. The entire description of our smart contract is recorded in our application ABI. And where do we get our ABI? Let me check. We get it somewhere here, our application ABI. Where did I get this ABI last time? Okay, good. Go to compiler. Go to compiler. Good. Here's the ABI. So you click on ABI, or you go to compilation details. It's better. So good. So you can see. Now, before I come here, let me close this so that you have to make sure is ERC20 payment. So make sure you select that contract, ERC20 payment, before you go to ABI. So before you go to, okay, oh sorry, I copied the ABI. Before you go to compilation details, so you can see these are the entire compilation details. You're going to see the Web3, how to deploy your application on how to deploy your application on the HTML itself on your like Web3 deploy. This is just what I mean. You can deploy this application by clicking a button on, by typing this code, and then let's just say clicking a button on your web page, and then you can deploy this application just the way we deployed here. Anyway, that's not what we're interested in right now. So where's our ABI? So here is our ABI. So let's just copy this. You can expand it a little to see what it means. It describes our application. So you can see describe our application with all the functions and everything. So let's just copy this ABI. And if you click here, you see what it means, describing all the functions, input and output parameters, scope, and the rest. So we've copied the ABI and then we paste it here. So you can see it's a long code. Now we have our ABI. So I can just close this like this. So that describes our application function and everything that we can interact with through Web3. So let's put our contract address. Contract address. So where is our contract address? Is this. So let's copy this. Then we connect to our contracts. We connect our contracts to our ABI. So let me see my ABI. That's a web3 eth.contract. So ABI, connect to our ABI. Now let's just get now my function. So we're going to call the function, but let's initialize it first. So it would be, we get the function from the ABI, which is at contract address. Contract address, good. So let's call the first function, which is the name of the token. So I see my function. Now this should be the list of also name, because the function, that we have a function called name here, which is the name of the token. That should be in ERC20. So we are calling this function, or rather the ERC20 detail, sorry. Good, so we're calling this function name, to return the name of the token. See if you can remember. So name, so we call the function, and then of course we have function on error, and then let's just say x name. So good. So if there's an error, then we can just write the error on a console, for example. For those using Node, this will go well with you. So we'll just display the error, or we can display it maybe on our HTML page. So but if not, then if x name, that's if we've gotten the name, then we do this. So we display this document. Let's get elements by ID. I believe we have x name here defined to get the name. Okay, good. So we want to display the name of the token here. So x name, that's inner HTML, and then we call this x name, right? So we'll display that. Okay, good. So but if there's an error, let's just display it on MetaMask here. So we'll just say documents, let's get elements by ID, MetaMask inner HTML, so we can display the error if there's an error. So let's run this and see. Like I said, before you run this, make sure your MetaMask is up and running and you're signed in. So let's refresh this page, and hopefully we should get the token name. Good. So we have the token name. So you can see we've interacted with our smart contract. No database, nothing. So using similar fashion, we can get the token symbol and total supply. So to quickly do that, I just copy this whole function and then just paste it here, and then just change some few things like name here. What I want is symbol, so I can just say symbol because we have these. If you look at good, we have a function called symbol that returns a symbol. We have a function called decimal that returns the decimal if we want to return the decimal. Okay, good. So symbol, and then I believe we have a HTML element called symbol. So I can just come here and say symbol and display symbol. So if I refresh this, I should be able to get the symbol. Good, so I've gotten the symbol. Now interacting with a smart contract, calling the smart contract requires no payment of gas because you're not actually adding records to the blockchain. You're only displaying records from the blockchain. So total supply, now we want to know the total supply. Now which function are we going to interact with? We should look at, because we've done a whole lot of inheritance, getting total supply should be on our payments, I believe. Returning total supply, do we have it here? Okay, no, oh, it's in our ERC20 rather. So it's in our ERC20. Good. So here we have a function that returns the total supply, which is this. Now it's still the same thing, same simple thing. Yeah, I can copy this function again. Let me look at the name properly. Total supply with capital S. So my function dot total supply. Let me see, what did I name here? X total supply. So I'm gonna say X. These are just naming convention. As total supply. So if, okay, here is supposed to be if X symbol is correct. So if X total supply, then total supply should display here. X total supply, which for now should return 0. Good. So our total supply is 0. Now we can check the balance of logged in accounts, which is we'll retrieve the logged in account and check its balance. Of course it's going to be 0 first because we've not minted any token yet. So to check the balance, we can create another function. Since we have get value, we can create another function called check balance. So I can just come down here, say function check balance. Now the same thing, we instantiate our contract ABI. We get our contract ABI, get our contract address, instantiate the ABI, connects our function to our ABI, and then do call our function. So it's pretty much the same thing. So to do that, I can just copy this first part of the contract of the Web3 code and paste it here because it's all the same thing. Good. So it's virtually the same thing. So I have this now, and then Now I need to display my contract. I need to display the logged in account address. Now to do that, here is the code that I need to write. So just put this at the top before the API, so I can say my web3. I'm creating another instance of web3 objects to connect to MetaMask. So my web3, and then window dot web3 dot current provider. Now you have to be careful here, because there are new security rules that MetaMask has added, new security features. Now we can't read account address like before, so they've added some new security checks. So if you want an application to be able to read your account address, to read your account, you need to do this. So you open MetaMask. Let me show you that. You open MetaMask, click on this icon here, go to settings, go to connection. You can see sites allowed to read your accounts. So you can see I've added localhost. So I've added remix.ethereum.org. Okay, you might have actually had this error in the beginning, so I already mentioned this. You might have actually had an error connecting your web3 to deploy your application. So make sure that remix.ethereum.org is added to sites that can manually that can read your account. So manually add a site to allow you to access your accounts, useful for older dApps. So I've added localhost, I've added this application one-click.dApp.com. so these are, and then localhost, so you can see, and you can remove a site. So if you don't add this, it's going to be difficult for you to read to do what we are doing here. So once you've added this, that is done. Now we connect this to our current provider, and then we can display it. So let's display it on our X account, right? We have our X address, account address, we call it X address. So we can say document.get elements by ID, just to display that. I can put that here. Document.get elements by ID, X address, inner HTML should be my web3, dot eth dot accounts. So I'm reading the first account. Good. So once I refresh this, okay, I need to call this, I need to call the check balance. So I need to call the check balance on this button here. So I can say on click, check balance. So this way I can run that to retrieve the address of the logged in account. Okay, are we having any mistake? Check balance, X address, hope I'm correct. Hope I'm correct. Check balance. Yes, I'm correct. X address. Okay, let me refresh this again. Okay, what could be the issue? Why am I not getting that? Click check balance. Anyway, let me display the account balance and see X balance. Let me do that and see. Let me do that and see. Let me call the balance of function. So function balance of this function here, we're calling it here, it's this balance of. So this is a function I'm calling. So balance of, you can see the parameter is an account, so we'll provide the account. So balance of, so we call my web3 that I declared eth.accounts. And then function error and X balance, since we are retrieving the balance. Right, since we're retrieving the balance, so it's pretty much the same thing. We say if there is an error, and of course we display the error. We can say console.log error. If not that, so if X balance, then we say document, let's get elements by ID, X balance, inner HTML should display this on X balance, right? And then we end this here. Now let me check this. Let me make sure this is correct. Let's run this again. Okay. Oh, I guess there is a problem somewhere. Constant my web3. What's a new web3 object? Window.web3.current provider. Am I making any mistake? Is the C capital C? I don't think so. Let me remove these and see. Wow, this is a problem. Okay, let me try and debug this a little and see what the problem is. Let me see whether this function itself is running. So let me just display this and see. Let me display these and see whether I'm having a problem running this function. Okay, good. So the problem should be from my codes. Current provider, is it capital P or small p? I can't remember. Maybe we could Google that and check. Capital P, and then let's change this to capital C and C, but I doubt. I believe it's small c, and then wow. Okay, balance off. Oh, there must be an issue somewhere. Okay, I guess I'll look at this and then come back here. I guess I'll pause the video now and then look at these, and we'll just continue from the next session and see the reason I'm having this, where I can display the address and the balance even though the codes look very okay to me. Okay, so let me pause this video here. We shall continue in the next session. Thank you. Okay, let's continue from where we stopped in the last video. We actually had an error trying to check the balance login account, and what really happened was it was a very simple error. Here I had this in small letter W. It's supposed to be in capital letter, and that's just it. So I will change this back to capital letter W and then save that. So you can see I've run this and I have the current logged in account with the balance. So okay, good. So you check these now and then you have the balance. Now this is because we've not minted any tokens yet, and that's why we're having the balance 0 and total supply 0. So now let's go ahead and code the mint token function. So it's going to be pretty much the same thing. Let's go back to the mint let's go to the mint token, and then of course we've defined everything. X here should be X account and X amount, right? Okay, I need to remove this. Why did I have this here? Okay, X account and X amount. So I'm going to create a function called mint. I'm going to create a function called mint, but I can actually copy these codes here and make my necessary changes. You know, I can actually copy all these codes here. I'll come to the mint token and then make my necessary changes. Like I don't need this function. I can call this mint, you know. Okay, I need a contract address. I need to do this connection, and then I just need to make a function call. So I can actually remove all these other functions. They're not necessary for now. And then the check balance function, of course I don't need that too. And then I can call these MetaMask. So good. So I'm going to modify this function to be able to mint tokens. But now, before I do that, if you look at our mint token or smart contract, if you look at our mint token function, you can see that we are checking. It requires that the mint address has to be the current address that is we're checking that this address has to have the role, has to have the minter rule, you know, before we're able to send tokens. So, and then when we instantiate, and of course the minters are actually in arrays, so you know we actually created an arrays of minters and bonus. So here's what we're going to do. Here now we just declare this. I'll say variable the account I'm sending to, so should be document get elements by ID x accounts, which I already have defined that, dot value, not dot inner HTML now. Okay, then variable amounts should be document.get element ID x amount dot value. So x accounts and x amount has been defined here. X account and x amount, and then of course I can just put the on click means. Good. So now the function call, it's going to be a bit different from what we have. So my function dot means, because we're sending a transaction now to the blockchain to sign, so we change this to send, because we're not calling, send transaction. And then of course we'll have to pass in the parameters. So we have two parameters, the account we're sending to and the amount. So we pass in these. So I said account to string, and then amount and then amount, can put that to string too. Okay, then now since we're sending a transaction, so we are going to have something like this. So we're sending it from Web3, so I'll just quickly change this from Web3 dot ETH dot accounts, of course, which is the logged in accounts, because we'll have to check the account that is doing that. This is the logged in account, and it has the minter rule. So this should start from here. Should have these like this. And then we'll supply the gas. We'll put this 1 2 3 1 2 3. This is okay. This is usually okay. And then so put our function here. So we'll say function. We have error and results. We'll change this to results. Okay, good. So if there's an error, we display the error, but then if there's an error, we display that. If there is no error, let's start with this. If there is no error, then we can display the results. You know, we can say console.log results. That is for those ones using else. If there's an error, I can just make this an if else statement. I can just say else here. put it like this so you can get to easily understand these codes. Good. So else, if there's an error, we can just display this on MetaMask. And then we display the error. So good. So here now we can mint functions now. We can mint tokens rather now from this. So let's attempt to do that. So I want to mint tokens to another address. Let me start from that. Let me copy the address. I have another address here I'm going to copy from. And that's the second address. I'm just going to copy that, which is my second account 2. Good. So I can copy this and then I can paste these on my notepad. So I can paste these on my notepad, which is this. Good. So I'm going to use that second address now. Now let's go to the mint function. So the recipient's address should be this, and then let's say I'm putting in 10,000 tokens of this. So let's mint this address. But okay, sorry, I have to be on the account that has the access rule to be able to mint tokens, not the second account. It's the first account actually. Good. So I should click on mint tokens. Okay, am I having any issue? Let me look at it. Mint tokens to this address. Okay, have I called the mint function? I don't think so. Okay, I've called it mint. Okay, I guess I'm having a small problem. Let me look at it, and then from web3.hth.accounts, the gas is these. And now we have function, and now we say if there's an error, so would log result, else. I don't need this actually. Do I need this? Else this, and then I can catch the error. And then where am I having this problem? Let me look at it. Where am I having this problem? Let's set these and run this again. Let me run these again. Okay, good. So you can see that error has been fixed. Now we're going to mint tokens, 10,000 tokens to this address. That will increase the total supply, and then and then increase the balance of the tokens. Okay, so we confirm this. So, well, we should have displayed whether it's successful or not, so that we can get to see the okay, well, it's successful, so we've minted that tokens. Now we can go back here now and see that our total supply has increased. You can see our total supply is now 10,000 tokens, but if we check the balance of the logged in account, it's still zero because we've not minted tokens to that account. So you can see that's how we do that. So now we can mint tokens to that account, which is to the logged in account, which is this. Copy this, copy that account address. So we copy that account address, and then so I can copy this now. I can copy this, copy it to clipboard. So I paste this here, and then maybe I mint 30,000 of this token, and then I can add this to supply. So that means at the end of the day I'm going to have 40,000 tokens added to total supply. While the first account is 30,000 tokens, which is the logged in account, the second account is 10,000 tokens. Now we will change the second account and try to mint tokens, and you will see that we're going to have a problem because that account is not a minter role. It doesn't have the access to be able to mint tokens. So that's where access control works very well. So let's see this. Now you can see that I've added that, we've minted the tokens. Oh, transaction confirmed. So if you come here now, you will see that we have total 40,000 tokens. If we check the balance here, we have 30,000 here. Good. Now let's change to the second account that doesn't have the minter rule and try to mint tokens and see. We're going to have an error doing that. So let's just change the account to the second account. And then let's try to mint tokens. Let's say we want to mint 5,000 tokens. So let's say we want to mint 5,000 tokens. So let's wait for these and see. Let's confirm these, and let's see whether we're going to have a successful result or not. You can see transaction failed, transaction encountered an error. So if we look at this transaction, we are going to see the error because we are not able to mint tokens because the account doesn't have the roles accessibility to do that. So you can see how our roles is working fine and good. But now, of course, with the second account, we can make transfer. We can make transfer. It has 10,000 tokens, so we want to transfer 5,000 tokens to this first account here. So increasing the supply of these from 40,000, from 30,000 to 35,000, right? So let's say we're adding 5,000 tokens. We're transferring to these accounts. Oh, I've not coded the transfer yet. Sorry. Let me code the transfer, the approved spending, and the bond token. So we've coded the means. We've coded the means token. So now we go and code the transfer. Now, which is pretty much the same thing. So just only some few changes. So I need to move this X name here. It's not important. So we have X accounts and X amount. It's pretty much the same thing. I come here and I pick all these. And then I drop it here. Now I can change these. There's some few changes that I need to make. I can change these now to transfer. Change this to transfer, and then of course the accounts, the amounts, and then here I just don't need this because this has nothing to do with an array. So the transfer and the amount. I can even remove the toString if I don't really need it. Leave that here. And then I change this to transfer because the function name is called transfer. Good. So, and that's that. And then I change this to transfer. So I can now code the test the transfer token. So let's say the second account wants to transfer to the first account. Let me pick the first account. Or the first account wants to transfer to the second account. So I copy this on clipboard. So okay, let me just save this. So I have the two accounts instead of switching. So I want to transfer from the first account, the main account, into this. So that account has 30,000 tokens, right? Let's look at it again. That's 30,000 tokens. So I want to remove 5,000 tokens of that and send it to the other accounts. Good. I want to add 5,000 tokens to the already 10,000 tokens of this account. So So I make transfer of 5,000 tokens. Send tokens approved. So approved, signed, confirmed. So good. So I can go here now and check. MetaMask is still pending. The transaction is still pending. I just saw it. So we check the balance. It's still 30,000. Let's wait for the transaction to be signed and to be recorded in the blockchain. This is supposed to change to 25,000. So let's wait a little bit for the transaction to be. Transaction is still pending actually. transaction is still pending. The transaction is still pending. Okay, you can see it's still pending. So you can click on this to see the details. Probably I would have speed up this transaction by increasing the gas. Okay, good. So confirmed. So the tokens has been sent. So now if I click on this, you can see it has been reduced to 25,000, which means this other account has been increased to 15,000, while we have our total supply to still be at 40,000. So we've made transfer successfully. So let's look at the other account. Let's look at the other account, which is my second account. So, which is my other account. So I can check. You can see it's 15,000. So okay, good. So the next thing is we code the approved spending. It's virtually all the same thing. We are just only calling the contracts using different methods. So it's pretty much the same thing with transfer. So I just copy all these codes, go to approve.html, drop these, and everything here is pretty much the same. The only thing I just change is to approve. And then approve, and okay, we have X account and X amount, right? Let's just confirm that. Approve spending. I've copied all this, so I need to remove this guy here. So X account and X amount. So it's pretty much the same thing. Here is approve from the function approve that we have, and that's all. So we can call these on click, just call approve. On click we call approve, and then we save these. So we're in the second account, right? So this we can approve this first account to spend maybe 3,000 of that our token. So I can just copy this, paste it here, and see maybe these accounts can spend 3,000 of our tokens. So approve spending. Approve spending. Allow localhost to spend your undefined. It's actually not undefined, so good. Allow localhost to spend your my OP token. So it's asking me, do you trust this site? By granting this permission, you allow localhost to withdraw your token and automate transactions for you. Of course, this is transaction fee, so let's do that. So we believe this should be successful, and then it means the first account, this account is approved to spend this amount of tokens on our behalf. So that's that about the approved spending. And then last but not least should be the bond tokens. So let's remove tokens from supply. We'll have 40,000 tokens. Let's remove 1,000 tokens from supply, from probably the first account. So it's pretty much the same thing too, with the mint function. So you can look at the mint function, it's pretty much the same thing with the bond. So just copy this and go to bond.html. I drop this, change this to bond, BURN. And then I change this to bond. And then of course, I don't need this X name actually. So on click, we call the bond token smart contract. On click, BURN. So by doing this now, we're going to bond some tokens from the total supply. And if you remember, it's only the admin, which is my first account, which is this, that should be able to perform that function. So let's check, are we logged into that account? Okay, no, so we log into that account. And then now we remove some tokens from this account, maybe just one token, to decrease the supply. So let's remove 1,000 tokens from this account. So the total supply will now reduce from 40,000 tokens to 39,000 tokens. Okay, so we confirm this. So we have successfully removed 1,000 tokens from total supply. So you can see we have 39,000 tokens, and here we have 25,000 tokens. Good. And these other tokens now will now have been reduced. So if you've made it this far, congratulations, you're a full-fledged dApp developer, because we've covered a lot and then you've seen how everything is. So thank you for watching.